Hello, everyone. So we have a really nice base number problem from MATHCOUNTS. So let's start with the problem. So in base B, we have two ways. We have two numbers actually. R is given and then Q is given in two different ways. Okay, and based on that, what is the value of R in base 10? Okay, so if you have no idea about the base other bases, if you just use base 10, it's really the same as base 10. Like what we know. Let me just give you a background. So if you have like 2, 4, 5, this can be written as 2 times 10 squared because 2 times 100, and then 4 times 10 to the first, and then 5 times 10 to the 0. So we use this because this is like ones digit or units digit, and this is tens, this is 100, and that's why we multiply by some power of tens. So 10 to the second, 10 to the first, and 10 to the 0. And if you have, let's say, 41 point maybe 27, so you can write the same idea. So that's the units digit and like tens digit. So 4 times 10 to the first, and 1 times 10 to the 0, and then 2 times 10 to the negative first power, and 7 times 10 to the negative second. So this is what we do when we are dealing with base 10. But if you have some other bases, like when I say base 9, that means I'm gonna use only digits 0 through 8, not 9. In base 10, we just have the base, like digit are 0 through 9. So, and then in base 20, you have digit that is 0 through 19 and stuff like that. Again, that's basically but just quick background. So what we do with the base 10 is actually the same as other bases as well. So now I'm going to expand this number first. Okay, let me do that. So our number R is given 0.57, right? And then 57 is keep repeating, right? So what I'm going to do, I'm going to expand this number in terms of this place value. Okay, so that would be 5 times, since our number is in base B, so instead of tens, because this was like 10 to this like 0th power, first power, second power, because that is our place value of each of those digits in base 10. But if you do have some other base, instead of this like 10, we are going to make that B. So that could be written as B to the negative first power, and 7 times B to the negative second power, 5 times B to the negative third, and you can just keep writing those, okay? B to the negative 4, and you can just continue. So what I'm gonna do now, I'm gonna write these numbers in two different sum, because 5 and 7s cannot really add it together. So what I'm gonna do, I'm gonna combine 5s together and 7s together. So the 1 over b squared is, b to the negative first power is just 1 over b. Okay, and then this guy, b to the negative third, is 1 over b to the third. Okay, since this is multiplied by 5, this is multiplied by 5. And instead of multiplying all these 5 separately, I'm going to combine all these numbers and take 5 as a common factor. And then if you want to write the next number was actually 1 over b to the 5th power. And you can continue, but I'm going to stop at this point. And plus, and then I'm going to combine those 7s as well. Okay, these guys. So if I combine those, I will get something similar. Okay, so maybe I should have color coded, but that's okay. So I'm going to say this is going to be 7 times 1 over b squared, because b to the negative second power can be written that way. And this guy was 1 over b to the 4th and 1 over b to the 6th. And you can just stop at that point. So at this point, I'm going to actually remind you a geometry series. So we just need to remember so we can use that. So if you are not familiar with geometry series, it's okay. It's just basically you add a bunch of numbers, but those bunch of numbers that you're adding has a relation. So you just get a number, next number by multiplying previous number by a common ratio, which is we call common ratio. And I'm going to say if your first number is A, you can multiply this by common ratio, which is AR. Okay, and then if you multiply AR by common ratio, which is R, that will be AR times R, which is R squared. And if you keep adding these, okay, so you can just continue this forever. If you do this infinitely many terms like this is equal to our first term a over my 1 minus r if your r is lesser than 1. Okay, so it might be larger than -1 as well, but this is not really our focus in this case. So this is our sum of the numbers in a geometric series if your common ratio is lesser than 1. So in our case, how do I know that my common ratio is lesser than 1? Because, you know, b is our base, which is at least 8. So b is something larger than 7 because of digits 5 and 7 also used in my base b number. So 1 over b squared, 1 over b is 1 over at least 8. So if you divide 1 by 8 or something bigger, so you will get something smaller than 1 for sure. And if you look at these numbers, all of these numbers 1 over b to the some power. Since b is larger than 7 at least, 1 over b to the some power is always lesser than 1. So, and that's one thing. And the second thing, when you look at these terms, you know, this is my first term, this is second term. If you multiply the first by 1 over b squared, you do get this guy. And then if you multiply this guy by 1 over b squared, you do get this guy, which means our first term in this case, maybe I should write that. So our first term in that parenthesis is 1 over b, and common ratio is 1 over b squared. Okay, so based on that, okay, I can continue this r, so that would be 5 times. Our first term is 1 over b, so 1 over b over our ratio is 1 over b squared, so 1 minus our common ratio was our sum of the numbers in that series actually. And that is the first part, 5 times parentheses is equal to this guy. And if I do the same thing with the second part, that is 7 times. Again, in this case, 1 over b squared is our first term. And then if you multiply this by 1 over b squared, you get b to the fourth. And if you multiply b squared, 1 over b squared, you get this guy, which means common ratio is 1 over b squared as well. So our first term is 1 over b squared over 1 minus common ratio. Common ratio is also 1 over b squared. And this parenthesis same as this guy, okay? And then this parenthesis, let me write this way. So the inside of this parenthesis is actually right here, this parenthesis, okay? And then inside of the second parenthesis, right here is the same as this fraction. So what we want to do now, just simplify these two expressions, okay? So if you like, you know, this is b squared over b squared, so that means this denominator b squared minus 1 over b squared. Since we have divided two fractions, so 5 times b 1 over b, 5 over b times, take the reciprocal out of the denominator, so that will be b squared minus 1, and that will be 7 over b squared times, since the denominator is the same thing, b squared over b squared minus 1. So these guys will cancel. One of these b's will cancel. And then that is 5b plus 7 over b squared minus 1. Again, this is our r. So just keep this in mind. Let's leave it for now. So this is my r. And I'm going to do something similar with our second number. But even though it looks like kind of complicated, more complicated than this, it looks like at least, but it's not really the case. The second one is actually less work than this. So 3r is like, I'm gonna split this 1 point something as 1 plus that something. Okay, so that is 1.0606 and 06, right? And you can continue. Since 0 doesn't add up anything, so I'm just gonna find just some of those 6, right? So that will be 1 plus 6 times, in our case, base is still b, okay? And b to the negative second power, 6 times b to the negative fourth power, because you have some digit in between those zeros, in between those sixes. Okay, and then 6 times b to the negative 6. And you can continue forever, but we don't need that part. and 1 plus 6 times 1 over b squared, 1 over b to the 4th. Okay, and then let me write this, 1 over b to the 6th, and you can continue if you like. So this is also geometric series because if you multiply this by 1 over b squared, you get this. If you multiply this by 1 over b squared, you got this. So the common ratio is still 1 over b squared as this guy. So the sum of the numbers in that parentheses is 1 plus 6 times, okay, our first term is 1 over b squared over 1 minus common ratio. Common ratio is 1 over b squared as well. Okay, so that is this parenthesis. Okay, and then if you simplify this a bit, so you know this is kind of same as this fraction. So this one will be b squared minus 1 over b squared. If you multiply this by 1 over b squared will cancel. Let me actually write it, 1 plus 6 times 1 over b squared times b squared over b squared minus 1. These guys will cancel. And instead of 1, I can write b squared minus 1, okay, over b squared minus 1, plus 6 over something. So if you add 6 to that guy, so that will be b squared plus 5 over b squared minus 1. So this is equal to 3r. Okay, so b squared plus 5 over same thing. So this was r. So if you combine those two now together, so let me do that. So I'm going to multiply r by 3. So that will be 3 times of this fraction, which is 15 b plus 21 over b squared minus 1. Now this is 3r. This was also 3r. B squared plus 5 over b squared minus 1. Since we can easily eliminate these guys and then maybe subtract these from both sides, so b squared, subtract 15b from both sides, minus 15b, subtract 21 from both sides. So that should be minus 16. At this point, you can use whatever you want, like quadratic formula or factoring, maybe complete square. But I'm going to factor because this guy is negative 16 times plus 1. And then if you add those, you got middle coefficient, which is good. So that's minus b minus 16 times b plus 1 equals 0. If the product is 0, that means b minus 16 should be 0 and b plus 1 should be 0. So which makes those numbers are negative 1 or 16. But that cannot be our answer because we are talking about b as base, which is at least larger than 7. So b has to be 16. But we want to be answering, like we want to answer the question, like b is 16, and then we are looking for the r. So r was equal to 5b over 5b plus 7 over this guy. So that will be 5 times 16 plus 7 over 16 squared plus minus 1, right? And that's 80, 87. And this is 256, 16 squared minus 1 is 255. Okay, so you know, if you add a digit, that's 15, which is divisible by 3, and that's 12, that's also. So if you divide by 3, that's 29. Then that would be, I guess, 2. If you divide this by 3, I guess it's 85, right? Let me double check. So if you divide this by 3, you got 8, 25, yeah, 85. Okay, and then 29 is a prime number, so that needs to be our simplest answer, okay? So I hope that makes sense. Again, we did a lot of work, but that was a number 27 on a state level. So I guess that's okay. I'll see you in next video, okay? Bye.